Today, we will talk about what is the blockchain trilemma. Blockchains can only handle a limited number of transactions per second. The Bitcoin network, for example, can process around 7 transactions per second. If blockchain technology is to be adopted globally, it should be able to handle much more data and at faster speeds so that more people can use the network without it becoming too slow or expensive to use. However, the fundamental design of many decentralized networks means that increasing scalability tends to weaken decentralization or security. This is what's known as the blockchain trilemma. Developers looking to solve this problem are experimenting with different consensus mechanisms and scalability solutions, such as sharding, sidechains, and state channels. In basic terms, a blockchain is a distributed digital database. Blocks of data are organized in chronological order. The blocks are linked and secured by cryptographic proofs. The implementation of this technology across different industries is already changing how we work and live. The idea is that decentralized and secure blockchains allow for a world where we don't need to rely on third parties for networks or markets to function. However, experts generally agree that if this tech is to be more widely adopted, there's a core problem that needs solving. The problem in question is known as the blockchain trilemma. This term was popularized by Ethereum co-founder Vitalik Buterin. For it to make sense, you need to be aware of 3 different elements that are desirable in a blockchain: decentralization, security, and scalability. The blockchain trilemma refers to the idea that it's hard for blockchains to achieve optimal levels of all 3 properties simultaneously. Increasing one usually leads to a weakening of another. What is decentralization? Bitcoin and similar blockchain networks are decentralized by design. The whole structure is such that there is no one person or organization in charge. Rather, it is decentralized. The network layer is open to anyone who wants to participate. As a result, control is fully distributed rather than held by one single entity. Everyone has access to the same data. If anyone tries to cheat the system by changing the records in their favor, then the rest of the participants will reject the faulty data. This can get quite technical, but let's take the Bitcoin network as an example. There is no third party in control. Compare this with the need for banks in the financial system. The banks enforce trust between people transacting and ensure all records are kept correctly. The Bitcoin blockchain, however, shares all that data with everyone on the network, so that it can be checked and confirmed before being added to the digital database. The result is a system that can exist without the need for third parties. Decentralization offers the possibility of what is known as Web 3. Right now we have Web 2, the Internet of today. It's full of sites and apps controlled by companies, but featuring content made by the users. Web 3 is the next step, an internet where decentralized blockchain tech lets people control their own data and online lives. One thing to note, however, is that because of how these distributed systems work, with a need for a wide range of participants to agree on the validity of any data, transaction times can be slow due to the way information needs to be shared and processed. And so, blockchains need to scale, which is to say be capable of handling more data at faster speeds. We'll come back to this point when discussing scalability. Additionally, the decentralized dream only holds if the underlying blockchains are secure. If a blockchain lacks security, then a bad actor can take control and change the data in their favor. This leads to the second part of the trilemma: security. What is blockchain security? It doesn't matter how decentralized a blockchain is if it lacks security. A good blockchain network should be resistant to attacks from malicious entities. Centralized systems derive their security from the fact that the system is closed. Whoever is in control can guarantee the data is free from interference. But how is this achieved in a decentralized system where anyone can take part? It's a complicated topic, but we can return to Bitcoin as an example of decentralized blockchain security. The Bitcoin blockchain uses a combination of cryptography and a network consensus mechanism called proof of work, POW. In terms of cryptography, each block has a kind of digital signature or hash. Each block of data is connected in a way that can't be tampered with because any changes would alter a block's hash. Any attempt to change the data would be quickly identified by the rest of the network. The POW consensus mechanism is another part of the puzzle. It helps secure the cryptocurrency's ledger. Understanding proof of work is a whole in itself, but for our purposes, note that members of the network can only verify new transactions and add them to the ledger through an activity known as mining. This involves using computational power to solve a mathematical puzzle. Part of the process requires these computers to perform numerous hashing functions. This plays into the issue of scalability, as the PELU mechanism is secure but relatively slow. Also note that the more participants, nodes, there are in the network, the more secure it is. The greater the number of parties, the harder it becomes for one bad actor to take control of the system. This relates to what is known as the 51% attack. As an overview, if a single entity or group of bad actors can control more than 50% of a blockchain's total network hashing rate, then they would be able to override consensus and change the chain's data to benefit themselves, such as double spending tokens. In short, security is a fundamental requirement for a blockchain to be successful because without it, attackers can take control of the chain, rendering it useless. What is scalability? Scalability refers to the goal of building a blockchain that can support more and more transactions per second. Scale is required if blockchain tech is to serve wider society and possibly billions of users. But this is where a lot of blockchains still struggle. This is because decentralization and security are so fundamental to blockchain that they tend to be focused on first. Decentralization is so central to the ethos and goals of blockchain that it lies at the very heart of most recognized blockchains. Security, as we've discussed, is a core requirement for a blockchain to be successful and useful. Why the blockchain trilemma exists? The most obvious and basic solution to the problem outlined above is to reduce the number of participants confirming and adding to the network data in exchange for greater scale and speed. But doing so would lead to a weakening of decentralization with control handed to a smaller number of participants. And it would also lead to a weakening of security as fewer players mean a higher chance of attacks. What do you think of our video? Let me know in the comments section below. Before you go, please hit the like button and subscribe to my channel. Thanks for watching.